Let me record these. Okay, so 1G asks us to graph y equals 2 sine of 6x minus pi over 2, right? Okay, so the first thing when you're going to graph stuff, you want to think about what's the amplitude, what's the period, what's the phase shift. So the amplitude, remember, is the number in front of the trig equation. So this 2 here, that's the amplitude. And it's the absolute value of that. Right now 2 happens to be positive, so it would be the absolute value of 2. So in our case, that's still 2. The period, if you remember, is 2 pi over b. And b is this number that's right in front of the x. So it's going to be 2 pi over 6, or that reduces to pi over 3. And then the phase shift, remember, is c over b. And so this here is our c. But this, remember, when you find c, that has to be a negative sign in the middle. So if it had been, like 6x plus pi over 2, that's when we rewrote it as 6x minus pi over 2, right? So if it's a positive, you have to think about rewriting it so you have a negative in there. So in our case, c over b is going to be pi over 2 divided by 6. So that's going to be pi over 2 times, you can think of this as 6 over 1, so 1 over 6, or pi over 12. So questions so far on any of those pieces? Okay, so then when I go to graph this, right, so the first thing I do is I'm going to draw my first kind of beginning part. So the first thing is a sine function, right? And so remember, our sine function looks like this. I'm making it dotted because this isn't going to be my final answer yet. And remember, this part out here, that one wave of the sine function, that's the period. So this right here is pi over 3. And we know that it's going too high and too low. And we need these 5 important points. So on the test, same thing, you have to be able to show me what those 5 important points are. And remember, we figured out there's these tick marks, right, on the axis. And the way that we figured them out was we found 1/4 of p, 1/2 of p, 3/4 of p. So 1/4 of p would be 1/4 times pi over 3, or pi over 12. 1/2 of p would be 1/2 times pi over 3, or pi over 6. And 3/4 p would be 3/4 times pi over 3. So the 3's would cancel, and that would be pi over 4. And those are the axes labels here. And I'll answer that question in 1 second. So this first one here is pi over 12. This is pi over 6. This is pi over 4. Okay, so we always have to change the sign to negative. Yeah, so if the original problem was not given to you as bx minus c, you have to change it so that it looks like bx minus c to get the phase shift. Yep. Other questions so far? Okay, so this is it's the basic sine function, and then I have, so I have the basic sine function, and then I also have, the amplitude going on correctly, right? And so now the thing I want to do is I want to So the thing I want to do now is I have to worry about the phase shift, right? So to worry about the phase shift, I am going to look at what the phase shift is. So in this case, the phase shift is pi over 12. And so that means each of these points have to move over a pi over 12. Now, here's the thing to notice. Pi over 12, if you were to start here, pi over 12 would move over. Okay, so this is a semantic point. The reason why the pi over 12 is not negative is because when we talk about phase shifts, so back in Math 126, right, when we saw something with a plus, we were like, oh, it moves left. And if we saw something with a minus, we're like, oh, it moves right. And so that's still the same thing. So we're basically saying we're moving to the right. And so because of that, we define the phase shift to be positive. So when we're talking about sines, we just define it a little bit differently than we did in Math 126. And so that's why we want it to be, if it's positive, we're going to the right. And if it's negative, we're going to the left. So that's why we are fitting it into the form y equals a either sine or cosine of bx minus c plus or minus d. So our generic form for the sine function has that bx minus c. And so that's why we're taking the positive pi over 2 and not the negative part. Does that help? No problem. So our phase shift is a pi over 12, so we're going to shift everything over to the right by pi over 12. But before I do that, I want to kind of label some more points on this axis. And so remember, once you find what this first one is, so this is 1 pi over 12. This point here is 2 pi over 12s, 3 pi over 12s, 4 pi over 12s, and I could keep labeling my axis going out. This would be 5 pi over 12s. The next one would be 6 pi over 12s. You could keep going, 7 pi over 12s. Yeah, so this is number 1G from the test review. So now I want to shift everything to the right by pi over 12. So this first point, which was here at 0, is now going to shift over to the right by pi over 12. This next point is going to shift over by a pi over 12. So each one of these tick marks is a pi over 12, so we're just shifting our graph over one tick mark. So our final answer is this blue graph here. Questions? No? Sure, you could use a different color. You could just make it darker. You could put an arrow to it and be like, this is my final answer. Any of those are completely fine with me. No problem. Other questions? Will graphs be provided on the exam? You mean like, will I tell you what like the sine graph looks like or the cosine graph looks like? I just want to make sure I'm answering the question. Okay, so you would just graph on your piece of paper. So just like I just graphed on my piece of paper, you would graph on your piece of paper. You're going to do all your work on a piece of paper. So you need to have a piece of paper for the test. You're going to do all your work on the piece of paper. So yeah, you want to draw it out, because the thing is I could put up a test, but then you'd have to be able to print it, right? So since we're not in a classroom, but this is all you would need to do for this graph, right? What I have here, so you could print the test, but depending like where you're going to print the test and stuff like that, like it could take time away from you working on the test. So, and the test isn't written where there's space for you to work problems underneath each problem. So, I'm going to write the test so it fits on the Zoom screen. So it's all going to be just problem after problem kind of all put together. So it'll be more like the review sheet. Like there's not room for you to work out the problems, on the test. But if you want to print it out, you can. Does that make sense? Okay. Other questions here on 1G. Yeah, so you can keep working. You just have to have stuff uploaded in that hour and 20 minutes long, right? So most people don't need 15 minutes to upload stuff. So no problem. Other questions? Okay. So then okay, that's fine. Confused on how we got our points. Okay, so the points, the blue points or the black points? Or you're talking about the labels on the axis, like the pi over 12, pi over 6, pi over 4? Okay. So the labels on the axes. So where I got them from, they all come from the period, right? So the first thing I do is I find the period. The period is pi over 3. So that tells me that one wave, one iteration of the wave, one cycle of the wave goes to pi over 3. So we're out here at pi over 3. And then there's a couple ways you can get those other points. Those other points, I put them over here. They are always going to be 1/4 of the period, 1/2 of the period, 3/4 of the period. Because you're literally taking this. I have basically, if you think about it, I have this chunk that starts at 0. It goes here to pi over 3. And I'm trying to split it into 4 equal pieces. So the other way you could think about doing it is I have pi over 3. If I split pi over 3 in half, that gives me pi over 6. If I split pi over 6 in half again, that gives me pi over 12. And then that's telling you that each of these tick marks is a pi over 12. So you could do then, 0, 1 pi over 12, 2 pi over 12. This would be 3 pi over 12. But 3 pi over 12 reduces to pi over 4. So there's a couple ways you could get those points. So one of the ways is to just think that's how long the end is, and then to start chopping up the interval. This part using these here, the 1/4 p, 1/2 p, 3/4 p, that works every single time. So the 1/4 p is always that first tick mark. The 1/2 p is always that second tick mark. The 3/4 p is that third tick mark. And then that end tick mark is always p. Does that help, Jolena? Okay. Other questions on this one before we do another one? Or go and do some other problems that people ask me to do. No? Okay. So let me copy this so that, we did one, I did 1G already. I don't know what happened there. Undo. All right, well, let me write these. So we have, because it doesn't want to let me copy. So 5, 4 minus 126. Okay, so 5, 4, the minus 120 degrees, 6. Okay, and then somebody sent me a message asking for the cotangent of 3, but that doesn't, 3 pi, 3 something, cotangent of 3 just by itself isn't something I would ask. So if you could just double check that problem. Okay, so let's look at 4. So, all right, so 4 had multiple parts. So obviously somebody definitely wants 4c. So 4c said, find the exact values of the trig functions for the following angle. And so the first one is minus 120 degrees. So I'm going to add in here the picture of the unit circle. Obviously, right, on the test, you would need to draw out the unit circle first, but let's have the... Okay, so, cotangent, 1f, cotangent of x. Yeah, I can do that in a second. So this is, whoops, this is 1f. Okay. All right. So for the test, right? So you're on Zoom, you take the test. When you're done with the test, and I will have these instructions up on Monday. When you're done with the test, what you'll do is you'll send me a private message to be like, Dr. Gorman, I'm done. So then I know that you are currently going to upload your test. So it depends. Depending what device you are, you might be able to stay on Zoom and upload your test, or you might not be able to, and that's okay. But you're telling me I'm done and I'm going to upload my test right now. So then I know that you're uploading your test. Does that make sense? No problem. Okay, so 4. All of the things in problem 4 are things that are on the unit circle, okay? So if I look at, here, I'm looking for minus 120 degrees. So if I need minus 120 degrees, if I start here, from here to here, that's minus 90 degrees, right? And so then if we go 30 more degrees, this here is minus 120 degrees. Right, so minus 120 degrees is this spoke here, and it asks for find the exact values of the trig functions for those angles. So we're looking for the sine of minus 120 degrees, the cosine of minus 120 degrees, the tangent of minus 120 degrees, the cosecant of minus 120 degrees, the secant of minus 120 degrees, and the cotangent of minus 120 degrees. And so the sine, remember sine is the y value, so the sine is going to be minus root 3 over 2. The cosine is the x value, so minus 1/2. The tangent is y over x, so in this case that's going to be y minus root 3 over 2, all divided by minus 1/2. So if I do keep change flip, I have minus root 3 over 2 times minus 2 over 1. Those would cancel. The negatives cancel each other out. So the tangent is just root 3. And then to get the cosecant, secant, and cotangent, we just flip them over. So the cosecant is minus 2 over root 3. The secant is minus 2. And the cotangent is going to be 1 over root 3. Does that help for whoever asked me about the negative 120? No problem. Other ones from problem number 4. Let's go with that. Sure, we can definitely do 4G. Oops. Put my guard back up here. So 4G. Okay, so 4G gives us pi over 2. So again, we're looking for the sine of pi over 2, the cosine of pi over 2, the tangent of pi over 2. I'm going to try to give myself a little bit more room this time. The cosecant of pi over 2, the secant of pi over 2, and the cotangent of pi over 2. Okay, so here's pi over 2, right? So we're looking for the sine is the y value. So the sine's going to be 1, the cosine's going to be 0. Tangent is y over x, right? So the y is 1 and the x is 0. Now, can I do 1 divided by 0? Okay, so some people said yes. Some people said no. Okay, so you can't do 1 divided by 0, right? So this is that idea. I think I talked about it in class. I said it's pizza math, right? So I have 1 pizza and there's nobody in a room. And so that doesn't make sense, right? How did the pizza get there? Who brought the pizza? So when you're dividing by 0, you're trying to split something evenly among 0 people, and that just doesn't make any sense. So 1 over 0 is actually what we say undefined. So the tangent of pi over 2 is undefined. And then we're going to flip them over. So if we flip them over, 1 over 1 is still just 1 for the cosecant. Here we would have 1 over 0 for the secant. So that's also same thing, undefined. And then the cotangent of pi over 2 would be 0 over 1. Now, 0 over 1, that's okay. That's saying I have no pizza and 1 person in a room. How much pizza is everybody going to get? Everybody's going to get no pizza. So that gives us 0 there. Does that help on 4G? No problem. Any other ones from problem 4? No. Okay. So I took care of 4, took care of the 120. All right, so 5, 6, and 1F. So let me go to the next page here. 5, 6, 1F. Okay, so 5. So I'm assuming you guys want to see both A and B and 5. So I'm going to add this unit circle back in again, just so we have it over here to reference. So 5A says find the cosine of 2 pi over 3 plus the cosine of pi over 6. So it's just asking you again values from the unit circle in a slightly different way. So if we look 2 pi over 3, so here is 2 pi over 3. And the cosine of 2 pi over 3, cosine is the x value, so it's going to be minus 1/2, plus the cosine of pi over 6, so here's pi over 6. And so the x value on pi over 6 is root 3 over 2, so plus root 3 over 2. So I can put them together since the denominators are the same. So this just is minus 1 plus root 3 all over 2. Does that make sense? People have questions on that one before I do 5B? And just a reminder, right, 5 does not match up with what is on the answer sheet, but I will fix it because I accidentally cut a question off of the review sheet. So I will fix it so the review sheet and the answers to the review sheet match up. So B is a similar thing, right? So sine 90 degrees plus cosine of 180 degrees times the sine of 120 degrees minus the sine of 0 degrees. So again, we're just going to pick these off, right? So the first one, sine of 90 degrees. 90 degrees is there, and so we're looking, sine is y, so it's going to be 1. So 1 plus cosine of 180 degrees. So here we are for 180 degrees. The cosine is the x, so it's a -1. So 1 plus -1 times The sine of 120, right? I happen to already have that circled. Sine, again, is the y value, so root 3 over 2. So root 3 over 2 minus the sine of 0 degrees. 0 degrees, the sine, the y value there is 0. So it's going to be minus 0. So we're going to end up with 1 minus root 3 over 2. And you could leave your answer like that, or you could put it together into one fraction. So 1 is the same as 2 over 2. So you'd have 2 over 2 minus root 3 over 2. So you could make it 2 minus root 3 all over 2. But you don't have to. You could stop here. I'm okay if you gave me that answer or if you give me this answer. Either one is fine. Other questions on 5? Okay, so 1 minus 1 is 0, but remember you have to do order of operations. So order of operations says that you do, so think about PEMDAS, right? So you do parentheses first, then exponents, which we don't have any of those here. But then you do multiplication and division in order from left to right. So we have to actually multiply negative 1 times root 3 over 2 first to get this minus root 3 over 2, and then we would do the subtraction. So you can't do the subtraction first and then the multiplication. So you guys can all now be experts at those, like, you know, people always argue over these types of problems on Facebook, right? But you have to do all of the multiplication and division first. No problem. Any other questions on this one? No. Okay. So we still have 6 and 1. 6, 1. Okay, so 6 will negative root 3 over 2 plus 1 be acceptable. For the previous one, yeah, that would be fine. That's not a problem. Okay. So 6 tells us, it says find the remaining trig values given that, so the tangent of theta equals minus 12 over 5, and they tell us that the sine of theta is greater than 0. Okay, so the first thing we have to do is we have to figure out where this angle theta is. So this uses, if you remember, we had that mnemonic, all students take calculus, right? And that told us about which trig functions were positive where. So for the all of the trig functions are positive. Student, only sine is positive. Take, only the tangent is positive. And calc, only the cosine is positive. And the ones that pair up with them, right? But remember, the all students take calculus just tells us about whether things are positive or negative for the sine, the cosine, and the tangent. Not the other things, not the other 3 other trig functions. Okay, so they give us some information. So if they're telling you here that the sine of theta is greater than 0, are they trying to tell you it's positive, the sine is positive, or the sine is negative? Okay, so they're trying to tell you that the sine is positive, right? So they're telling us right now, hey, the sine is positive, right? So we could, if the sine is positive, we could have an angle potentially in quadrant 1 or in quadrant 2. Those are the 2 places. The tangent is negative. So the quadrants that the tangent could be negative in is the tangent's negative in quadrant 2, and it's also negative in quadrant 4. So we're looking for the place that both of these things happen. So both of these 2 things happen in quadrant 2. So in quadrant 2, the tangent is negative, but the sine is positive, which means my angle theta is ending up here in quadrant 2. And so if I drop down to make a reference triangle, it's telling me the tangent is the opposite, 12, over the adjacent, 5. Now, they say it's negative 12 over 5. It doesn't mean that the negative has to go with the 12. The negative could go with the 12 or it could go with the 5. We have to figure it out. So if you think about looking at this, which one of these should be negative? Should the 12 be negative or the 5 be negative? Yeah, the 5 should be negative because we're on the negative part of the x-axis. So that's going to be negative 5. So now I just need to use the Pythagorean theorem to find the hypotenuse. So a squared plus b squared equals c squared. So 12 squared plus negative 5 squared equals c squared. So 144 plus 25 equals c squared. So 169 is equal to c squared. So if I take the square root, c is going to be equal to plus or minus the square root of 169. So c is going to be plus or minus 13. And because we're talking about the hypotenuse, we always have our hypotenuse be positive. So in this case, this measurement here is going to be 13. So now I have all the sides. So now I can just figure out all the trig values, right? So I'm looking for the sine of theta, the cosine of theta, the tangent of theta, which they already gave us the tangent, right? It's negative 12 over 5. The cosecant of theta, the secant of theta, and the cotangent of theta. So the sine is going to be the opposite 12 over the hypotenuse 13. The cosine is going to be the adjacent, so negative 5 over the hypotenuse 13. And then to get those other three, we just flip them over. So this is going to be 13 over 12. The secant is going to be negative 13 over 5. And the cotangent is going to be negative 5 over 12. Does that help? No problem. Other questions on 6? No. Okay, I can fit 1F right here. So 1F, so 1, A, B, C, D, E, and F are just asking you if you know the basic shape of the basic trig functions. So 1F is y equals the cotangent of x. So if we recall, the cotangent of x graph looked like this. So it came down that way, right? And it had all these asymptotes. And then we just have to label these. So obviously this is 0, right? And then the cotangent, so we have, so the cotangent is x over y, right? And so we need to basically label these points and label the asymptotes. Lost my word there. So these asymptotes are happening at multiples of pi. So pi, 2 pi, this would be minus pi, and then the places it crosses are at the multiples of pi over 2. So pi over 2, 3 pi over 2, this will be minus pi over 2. So that's all I'm looking for in 1F. Yeah, so problem number 1 just asked you to graph. So it said just sketch a graph. So it's not looking for you to solve any of the numbers or anything. It just wants the graph. All of the problems in number 1 want a graph. Yeah, you do have to label so for the cotangent, you have to label the cotangent and tangent, you have to label the x-axis. All the other graphs you should have the x-axis labeled, but then you also need a little bit of labeling on the y-axis. And I put up, you might have to draw them. So I haven't, like I said, I haven't written the test yet, so I'm not sure. In the past, sometimes I've had people draw them, sometimes I've had people have to identify, like tell me which graph this is. Sometimes I don't put any of those on, so it just kind of depends But I did put up on Canvas under Handouts, I did put up the sheet that has the graphs of each of them. So it should be there under the Handouts. Other questions? Can I do 1G? Yeah, isn't 1G what I did at the beginning? Yeah, so 1G was the very first one I did here. Do you have to do range and domain? So no. So on this test, I'm not gonna ask you to tell me the range and domain of things. The range and domain is going to come back for the second test when we begin to look at inverse trig functions. That's when the range and domain are important. But there won't be any questions on the test that I ask for the domain or range. No problem. Other questions? So in Alex, when you do the graphing, so if you plot my points, like here, like if you put into Alex these points, it should graph it correctly for you. So like, but you have to, there's a way, like in Alex, you can enter the point. So in Alex, there's like one of the buttons on the graph gives you, it looks kind of like this with like a little X. So it's like almost a little tiny graph with an X. That is where it'll allow you to type in points. So if you click that button, it'll pop up and say type in a point. So like this first point here, I would type in pi over 12 comma 0. This point here, I would type in pi over 6 comma 2. This one, pi over 4 comma 0, right? This one, pi over 3 comma negative 2, and this one here, 5 pi over 12 comma 0. So if you typed in those 5 points and then hit the graph button on Alex, it should make this curve for you. Does that help? Is that what you're asking? Great. Yeah, so as long as you identify, that's why I stressed picking these 5 points. As long as you can tell what happens to these 5 points, then it'll be fine on the exam and it'll be fine on Alex. So as long as you tell Alex, hey, graph these 5 points and then click the graph button, it should make a pretty nice graph for you. And if you still have problems, you can definitely send me an email so that I can go in and look at like your specific problems and see if I can figure out what's going on. Other questions? No? Nobody has any other questions? So next Wednesday we will start on new stuff. Yeah. So when I grade the tests, and since your test is Monday, I don't know if I'll have them graded by Wednesday. I will try, but I'm not positive it's gonna happen. It might. We'll see. So they'll definitely be graded by the following Monday. So I definitely have stuff graded within a week. But I will, when I grade the test, like I will make comments and stuff on your particular tests that then you can see. So yeah, so on Wednesday we will be starting a new chapter. Like next week, obviously. Today's Wednesday. So there is a study guide, right? So let me share that screen so that you guys can see what I am talking about. Just give me 1 second here. Okay. So if you go to our Math 127 homepage, right, like in Canvas, so you go to Canvas, open up Math 127, I have lots of goodies here for you, right? So just to kind of remind you about stuff. If you ever miss class, right, so after class is done, you can click on the class recordings, right, and I'll put the recordings up for you for those days, right, so you can rewatch class. Or, you know, even if you came to class but you want to rewatch something. There is, this is where the handouts section is, right? I referenced and I put up here, here's the graphs of the 6 trig functions. I put out a handout that has the whole entire unit circle filled in. So if we go back to the home page here, but here there's a button that says test reviews. So if you click on the test reviews, right, then it says click here for test 1 information and the review sheet. So it tells us, right, test 1 is on the February 22nd. You have an hour and 20 minutes to take the test and upload your answers to Canvas. You need to have your camera on. You should put your camera far enough back so I can see you writing. You're allowed to use your brain and a calculator during the test and no other resources. And then here is that review sheet. So where these problems have been taken from are from that review sheet, and then the answers to the review sheet. And I will upload a correct copy of this review sheet so that the numbers here match the problems on the review sheet. So yeah, so there's lots of goodies on the on that. Okay, so how are the answers going to be uploaded? So again, what'll happen is so yeah, the review sheet is the study guide. If you can do the problems on the review sheet and you understand the concepts, the problems on the test won't be exactly the same, but they're pretty similar. There might be 1 or 2 that are kind of a little different, but if you can understand the concepts on the review sheet, you shouldn't have a problem with those concepts on the test. So when it's time for the test, right, what'll happen is here under assignments, right, so right now it says it's not visible to you guys because there aren't any assignments there because I haven't written the test, but there will be on Monday, there will be a test here that will unlock when we have class, and then it will lock at the end of class. So under the assignments, you'll work the test problems out on paper, and then you'll upload it to that assignment on Canvas. Does that make sense? Other questions. And I should say, the stuff, Alex covers the stuff on the test too, like the homeworks that you've been doing on Alex covers stuff on the test, but there are some things in the homeworks that aren't on the test. So Alex kind of has like extra stuff, if that makes sense. Other questions? Yeah, if you can do the stuff on Alex, you should be fine, right? If I were you, I would look at the review sheet because that's kind of more like how the wording will be on the test so that you know what you're doing. But yeah, if you can do the stuff on Alex, then you shouldn't have a problem on the test. Other questions? No problem. You too. Yeah, so if no one has any other questions, right, my plan for the day was just to answer all of your questions. So you don't have to stick around. You're free to go. If people have questions and they want to keep asking, you're free to stick around and ask questions. No problem. Have a good one. See you Monday. I'll try. Thanks, you too. Okay, so yeah, let me share another screen. I'll share my iPad. So, okay, so just so that I know what you're asking. Are you asking? Oops. Okay. Are you asking where these numbers come from? Like how these numbers are here in the unit circle? Like, I just want to make sure I can, or like in the unit circle, you have the x and the y, right? And the x value represents the cosine and the y value represents the sine. So the x is the cosine, y is the sine. So, did I answer your question? I'm not sure if I answered your question yet or not. Oh, and I see that I didn't actually share my screen. Okay. So yeah, so this is what I wrote. So I put the unit circle up there, and then the x is the cosine and the y is the sine. And then the tangent is y over x. So that's how I was getting those. So if you know all those points on the unit circle, then if you were looking for, say, the sine of 11 pi over 6, I would go here to 11 pi over 6. Sine is the y value, so it would be minus 1/2. Does that help? Or did I not answer your question or explain it, the part you needed re-explained? Okay, so it's minus 1/2 because, so here I am at the 11 pi over 6, right? So at 11 pi over 6, this is the point. And at that point, the first thing is the x, the second thing is the y. So sine is y. So when you're trying to find the sine, you're trying to pull off the y value. And so if I look here, the y value is minus 1/2, so that's why the sine is minus 1/2. Does that help? No problem. No problem. Have a good weekend, too. Other questions? Thanks, you too. Thanks, you too.